question 7, we are given a uniform metal rod, which is AB here, length 30 centimeters and weight 10 newtons. So since it's a uniform rod, we can put its weight under gravity in the middle, so that's going to be 10 newtons. Each side of that then is going to be 0.15 meters. Okay, so we've got 0.15 meters. We are told that the rod is hinged to a smooth vertical wall at point A, so that's over here. So then we know there's going to be a reaction at point A. If you can remember then, with hinges, the reaction isn't perpendicular. Okay, so we're going to have the X component and the Y component of the reaction. We're then told a light horizontal cable attaches B to point C, so that's going to be up here. You're going to have the cable, and then we're going to have the tension in that cable. So here we're going to have our tension, and then at B we're told that a basket of 40 newtons is attached, so we're also going to have a weight of 40 newtons. Then of course we're told that the rod AB makes an angle of 60 degrees with the vertical wall. So we've got all our forces marked on. So in an exam then that would give us our 2 marks, and then we can go on, find the tension in BC, and then find the direction and the magnitude of the reaction at hinge A. So if we pop this to the side, we'll be using that again later, but for now if we just concentrate on taking moments in order to find the tension around B. So if we take moments around A, that's the easiest thing to do, because if we do that, that will eliminate the X and the Y. We won't have to consider those for this point, which is ideal because we don't need to know what they are at the minute. So if we take moments around A, we can say the clockwise moment will be equal to the anti-clockwise moment. And remember, we're looking at the perpendicular distances. So for perpendicular distances, we're going to have 10 multiplied by cosine 30. Okay, and that's because kind of this angle in here is 30 degrees. So you could have cosine 30, or you could have sine 60. It's entirely up to you. So we've got 10 cosine 30. That is 0.15 meters away. We then also have 40 cosine 30, which is 0.3 meters away, and that is equal to t sine 30 multiplied by 0.3. All we have to do now is work our way through that. So we're going to have 3 root 3 over 4 plus 6 root 3 equals 3t over 20 when we work all of that out, which then means we will have 3t is equal to 233.83, which means the tension will come out as 77.9 newtons, and that's that rounded to 3 significant figures. The exact figure is 77.942, which we'll need a wee bit later on when we're looking for the reaction. So we found the tension in the rope, which means now we can look at the reaction at the hinge A. Because the system is in equilibrium, we can look at the horizontal forces and say that they are equal. So we can say that X is equal to the tension, which then is just equal to 77.942. We can then look at the horizontal forces and say that Y is equal to 40 newtons plus 10 newtons, which is just 50 newtons. Once we've got the X and the Y, we can find the resultant of those two forces and then find the angle, which will tell us the direction. So we've got X, which is 77.942, and then our Y, which is 50. We find the resultant and the angle made of the horizontal. That will give us the magnitude and the direction of the reaction. So R will just be the square root of 77.942 squared plus 50 squared. Okay, so that's going to come out as 92.6 newtons, and that's the 3 significant figures. The angle then, theta, will be the inverse tan of the opposite over the adjacent, So 50 over 77.942, which will come out as 32.7 degrees above the horizontal.